Have you ever felt lost in a maze of data, struggling with the chaos of outdated file storage? Today, Vishwa guides us from the pitfalls of redundancy and inconsistency to the structured world of database management systems, where data doesn't just exist, it thrives in harmony. We're diving into the core of RDBMS, where relationships define success and primary, composite, and foreign keys unlock the DNA of data interconnectivity. Prepare to leave behind security lapses and scattered data as we explore the architecture that transforms data mess into meticulous design. Let's embrace the precision of RDBMS and start our journey to data clarity.
So in this segment, we are going to talk about relational database management system. But before we start talking about the relational database management system, let's try to understand what were, the previous way of storing the data. Because unless until we understand the challenges of the previous mode of storing data, it will be really tough for us to really appreciate the, the advantages or the benefits of the relational database management system. So let's go a little bit in the past and see how we have been storing data in the past. One of the most common way of the storing data has been the file-based storage system. So it is like, it is a hierarchical-based storage system. For example, if you have worked on any operating system, whether it's a Mac or Windows or the Linux, right? You would have observed that, whatever data that you store, whether a file, a text file or anything, it gets stored in some kind of hierarchical format. So for example, if you see here, right? We have taken an example of Linux in which this is the structure of how a file is stored. So there is a parent directory, then there is a subdirectory, and then there is a file. Similarly, another example is another directory. There is another subdirectory inside that. There is a further nesting of the directory, and then we have another file called file2. So the file-based storage is a kind of storage system in which you store the file in the hierarchical order in the form of the directories and the subdirectories. So this is how we have been using it over a period of time. It is a very simple and very very quick way of storing the data. But said that as we evolved, as the internet evolved, and as the the users of the data evolved, this way of storing the data started posing some of the challenges, and we're not able to scale and meet our current day requirements. So let's try to understand what are the biggest challenges of this file-based storage system were. One of the biggest challenges is redundancy. So what happens in a file-based storage is that there is no proper rule, there is no proper format, and there is no definite way of storing the data. As a result of which, you most of the time end up appending the new data one after the another, which in result, you end up storing the same data multiple times, which may have many shortfalls. Like for example, you have the data at the multiple places, you end up storing the more, taking up more storage and the more space. So this is one of the biggest problem with the file-based storage system is. The second is the complexity in the update. Now this again arises from the first point. So since if you have a data at the multiple places, and suppose in the future you have a requirement of updating it, you'll have to go and update at the multiple places, which again itself is a challenge. So again the updation adds a lots of complexity when you have to do in a file-based storage system. Now third, transaction. As I was saying, right, in the today's world, we are using computer everywhere. Take for example banking system, right? In a banking system, the money is involved. So everything that you do is atomic operation. Either the whole money transaction is successful or it is totally failed, right? It can't happen like if you're planning to transfer say 100 rupees and only like 10 rupees get transferred and the 19 rupees just got in between. It cannot happen, right? So these kind of file storage system, they do not guarantee transaction. They do not provide you the atomic operation. So again, we cannot leverage this file-based storage system in the scenarios where the transaction is needed. The fourth thing is the security. Nowadays, everywhere we have been talking about, the security concerns. People are too much concerned about how the data is secured. Is there any chance that a hacker can, start looking into or peeping into your data? Now, file-based storage system has only a trivial level of security layers. They can only give you a role-based security access. But in the today's more advanced world where nothing is secured these days, you need some additional layer of the security like two-factor authentication, username, password, better encryption ways, which are not actually provided by the file-based storage system. Then there's something called data integrity. So again, in the file-based storage system, right, there is no way that you can ensure or enforce a user to store only a specific kind of data, right? So for example, in the same file, you start storing first integers, then you can start ending the string, and then you can start ending any other format of data that you want. So there is no way that you can enforce this. So this again, adds a little bit of challenge, because you as a programmatically, when you have to read the data, you don't know what kind of format of data you are out to read. It can be a string, it can be integer, or it can be any other number. So on a high level, these are the challenges that the file-based systems has to offer. Now there are few more challenges, like for example, when the file-based system were being used for, like, say 10 years from now, mostly those time the use case were mostly mathematical. It will mostly around the numbers. But today, in the current scenario, our use case has changed. We are more into the real life problems. For example, take the example of the e-commerce company. They're trying to mimic the real world retail world on the online space. Take the example of, say, social networking site. They're trying to bring the relations, they're trying to bring the friendships among the people into an online world. So today, the way we have to store the data is too much related to the real life scenarios. They are too much relational. Now those kind of data, if we have to bring some relationship and want to store in a relational way, file-based storage systems really fails on those aspects, and as a result of which, we have to look up for a more better ways of storing the data, so that we can mimic that real life scenarios, maintain that relationships, and should be able to store that data in a more efficient way. So in the coming segment, what we'll talk about is that now since we have a proper understanding that where the file-based system failed, we'll try to understand like how relational database management system came for the rescue and help us in solving each of these problems.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by Upgrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
So in this segment, we'll talk more about the databases. Why databases are so important? So you take any industry these days, right? Whether it's a banking industry or an e-commerce or a social networking site, every application or every industry that you see has to store the data to back their application. A banking company needs that data storage to support, the user account information, that which user has holding how much of amount. For example, in the e-commerce company, they need to store the data to store the repository of all their products. They also have to store the user behavior data so that they can better provide a better custom view of their products to their users. Similarly, in the social networking sites, they need to store the user information. They also need to store the user behavior so that they can have the proper customized views to each of their users of their websites. So any application you take, whether a trivial or very complex one, every application at the end of the day needs some kind of data storage system. So database is everywhere, and it is a must for any application to survive. Now I understand that you guys would have heard a lot about the databases. So very simple question to all of you. MySQL and Oracle are one of the most common words that you would have heard. So are these databases? Just think twice and try to answer yourself. If your answer is yes, then it is wrong. MySQL and Oracle are not the actual databases. They are actually the relational database management system. There's a subtle difference between a database itself and what a database management system is. We'll try to talk more about it. So if we try to understand what a database is, and if we try to understand what a database management system is, database is actually the physical layer where the data is actually getting stored. The only layer where the data is getting stored is only what database is. So if I have to represent it diagrammatically, it is this layer where the data gets stored. So it only deals with the storage of the data, how it is getting stored and how it is getting queried. But that is not always enough. You always want to give the end user the capability to query and store data in it. For that, you have to write a software, you have to write the program, which is an added layer on the top of the database to retrieve that data. And that added layer is what is known as database management system. So a database management system is a collection of the programs, a library or a software which sits on the top of a database management, which sits on the top of a database to to retrieve the data, to query the data. So database management system sends the instruction to the database to either store the data or to retrieve the data. So any end user who is actually looking for the data, they cannot directly talk to a database. They will have to first talk to the database management system like this. So it is an end user and he is looking to store or retrieve data. So the end user will make a call to the database management system, which in turn will call the database to get or store data. So this is how the database and the database management system works. In the coming section, we'll be talking more about a different kind of database management systems which deals with more of a relationship, and that kind of database management system is known as the relational database management system. So we have studied about how primary key can help you to identify, the uniquely each of the record in a table. So when we have a primary key, we know how to retrieve a data from a single table. Now there's another important concept called foreign keys, which helps us in multiple ways. At one way, it helps in maintaining the relationship between the two tables, and at the same time, whenever there's a requirement of fetching the data from the multiple tables, the foreign key comes to the rescue. Let's try to understand how and what a foreign key with the help of the given example. So right now we have two tables with us. One is the employee table and another one is the department table. So the employee table, again, as we have already seen, has four fields. One is the employee ID, the another field is name, the third field is department ID, and the fourth field is salary. Now in this employee table, the primary key is the employee ID. So the employee ID is something which will uniquely identify each of the record of this employee table. Similarly, we have something called department table, which has two fields. It has the primary key as the department ID and it has another column called department name. Now, there are two use cases that we can solve with the help of the foreign keys. First, in understanding what is the relationship between the two tables. So suppose if we want to understand like which employee belongs to the which department, how do we do it? So to do that, the foreign keys comes to the help. So for example, in this, the department ID, which is the primary key of this department table, is also available in the employee table as one of the columns. Now, the department ID column in the employee table is acting as a kind of relationship identifier for a department table, and this column is known as the foreign key. What in other words it means is that a foreign key is a column in a table which acts as a primary identifier or a primary key in the other table. So this foreign key helps us in maintaining the relationship between the two tables. So this is one thing that it helps us to identify, that is the relationship. The another use of the foreign key is whenever we have to fetch the data from the two tables. So for example, if we are looking for a query in which I just not only want to know the details of the employee, but I also want to understand in which department it works. That is, I want to know the department name. Now that data is not available in one single table called employee, it is available in the two tables. So how do I do it? So in that case, with the help of the foreign key, I will be able to query two tables and not just one to get that data. So this is how we know the foreign key plays a very important role in maintaining the relationships, and it also helps you in writing a very efficient queries when you have to query the multiple tables. So just now we have given a small brief about what a primary key and a foreign key is. We'll talk more about the primary and the foreign key when we'll discuss more about the integrity, about the data integrity and the referential integrity. So we have talked about how we store data in the form of the tables in RDBMS. So with that, it is sorted out that how we store data. Now just storing data is not something that we want. We also want to retrieve that data. Let's take in the real world. How do we identify any person? To identify any person or anything, we always identify some kind of unique nomenclature, right? For example, if you have to call some of our friend, we just don't say, hey friend, we just say out a name, hey Rahul or hey Vishwa. And that is how we identify each of the real life entities. Similarly, in the case when we store data in the database world, there should be some identifier with the help of which you can uniquely identify each of the record. And the way to do is the help of a key known as the primary key. So primary key is the basic way of uniquely identifying each of the record in the relational database management system. Let's try to take an example and understand how it actually works out in the tabular format in RDBMS. So we have taken an example of employee table, right? And if we see, the employee table has 4 attributes or the 4 columns. The name of those attributes are employee ID, name, department ID, and the salary. Now each of the rows that you see now, for example row number 1, 2 and the 3, they are basically the record of each of the individual employees. Now my use case can be, I want to uniquely identify each of the employees. How do I do it? The only way to do is that there is some way or there is some identifier which distinguishes or which differentiate each of the employee record from the other. And this is how we do by using a unique naming convention or the unique numbering for the employee ID. So for example, the employee name Vishwa has a unique employee ID of 1 and the employee name Mohan has a unique employee ID of 2. So here this employee ID is acting as a identifier for each of the employee record, and I call this employee ID as the primary key. So in this table, just this employee ID, a single column is sufficient to uniquely identify each of the rows. So in this table employee, I call the primary key as employee ID column. So this is how we do in this table. But all the time, the way we store data into the tables, it may not be possible to uniquely identify each of the rows in a table by a single column, right? In that case, we'll have to take help of the multiple columns to identify a unique combination. Let's try to see that with the help of another example. So for example, in the student table, it has 3 columns. The first column is student, the second column is batch, and the third column is marks. If you see in this table, each of the column, the values, if you look at the values of each of the columns, none of them are unique, right? So you cannot, if we just take one column value, we cannot uniquely identify any of the columns. So what we do, we combine multiple columns to find a unique value. So for example, in this, if I combine the student ID and a batch together, this will act as a unique combination and will help us to uniquely identify any particular column. So in this case, my primary key will be a composite key which will be a combination of student ID plus it will be a combination of the batch. So depending on the kind of the table you have, the idea of the primary key is that it will be a single column or a combination of column which can uniquely identify each of the records, each of the rows of a given table. We have already discussed about database and database management system and how they subtly differ from each other. Now we'll talk more about the relation, how the relation comes into the picture in the database management system. We'll start with an example. Take an example of an office setting in the real life world and keep it very simple. So right now in the office, we suppose there are 2 entities in the office. One is the employee itself and the another entity is say the department. Now each of the employee to work in that office has to be related. What I mean by relation is that has to be a part of some department, right? So every employee will have some kind of department ID associated with it. And now suppose you want to store this information of this office programmatically in the world of database management system. Now you not only have to store the data, but you also have to store that relationship, right? And this is what we'll try to understand in the how we do it in the relational database management system world. So we'll take the example of the different features of the relational database management system one after the another, and we'll try to understand how this relationship works. So the very first and the important feature of any relational database management system is table. So as you can see in this table, we have an employee table, right? So every table should have a name. For example, this table has a name called employee. Also, any table in a relational database world is always in the form of a matrix. It will be in the form of the rows and the column. The first row of any table actually indicates what is the heading, what is the name of the different fields. So for example, in this employee table, we have the different fields like employee ID, we have the name like employee name, we have the field like department ID, and we have something called salary. So every time in any table, the first row will indicate the different fields of that particular table. All the following rows of a particular table will indicate what are the different values that or the attributes that particular entity has. So for example, in this table, in the employee table, some of the employee can have employee ID 1, they can have a name as Vishwa, they can have, the department ID as D01 and a salary of 55,000. Similarly, we have another table called department, which has basically, two columns. The first column is indicating the department ID and the second column is representing what that department ID belongs to, means like which department it belongs to. Now let's try to understand how the relationship is coming into the picture in this two tables, right? So just like in the real life scenario in an office setting, the every employee is related to a department. Similarly, if we see this table and if we see department table, we find that in every employee table there is a column called department ID, which indicates like which employee belongs to which department, and this is how you maintain a relationship between the two tables. So this is the first feature about relational database management system, which is tabular representation of data. We will be following up with more features on this relational database management system in the coming video.
Transitioning from data chaos to clarity is an ongoing challenge. आगे की सोचो so you can continue to refine your expertise in database management systems with Upgrad and stay prepared for the future of data management.